Hi everybody, welcome to another video in linear algebra, section 1.6, application of linear system. So in this section we only do some application of linear system. There will be a lot of application in linear algebra. Here's only a few of them. So the first we have the homogeneous system in economics. Suppose a nation economy is divided into many sectors, and suppose that each sector we know is a total output for 1 year, and we know exactly how this output is divided among the other sectors of economy. The total dollar values of the sector output called the price of output. Right. So Leontief proved that there exists equilibrium prices that can be assigned to the total output of the various sectors in such a way that the income of each sector exactly balance its expense. So what does that mean? I would actually just look at the example that will get an idea of what we're dealing with. So suppose we have the economy only have 3 sectors, coal, electric, and steel. 3 of them. Of course there are a lot more, but let's just concentrate to those 3. And those 3 will interact like this. The coal, of course, then get nothing from coal, right? This the you see all of this add up to 1, right? And notice that. So the coal sector will supply 0% of their production to coal. The coal supply 60% of their production into electric. The coal supply 40% of their products into steel. Now, electric will supply 40% to the coal sector. 1% of that supply to electric. So it does take some electricity to run electricity. It takes some power to produce some power. But most of all, the electric will supply 50% of their production into steel. And steel supplies 60% to coal, 20% to electric, and 2% to steel. Right. And the equilibrium price, but actually it would think about is it the total values of the production of the whole sector. So we say, but in this the way we write this, we just say prices. So we use P. So let P of C A S be the price. The price of the output, or we say the values of the production of the whole thing, be the price of coal, electric, and steel respectively. Then we can write as like this. Then this we say the total production of coal, 0% of that coal, the price for coal is 0 from coal and 0.4 from electric and 0.6 from steel. So the coal we purchase, nothing from coal, 40% of the total electric values and 60% of total electric steel. And if we want equilibrium, this will have to be equal to the total values of coal. And likewise, the second equation we can say 0.6 times the total values of coal, 0.1 or we just say the price of electric, and 0.2 the price of steel, and all the prices add up will be balanced out with the values of electric. So we want equilibrium, so that will make this equal. And then same thing here, we will have 0.4 40% of the values of coal, 50% of the values of electric, and then 20% the values of steel. Add all of them up is the total values of steel. Right? Now this is called the homogeneous system of economics. So homogeneous meaning that we have 0 on the right hand side. So it's easy, we just subtract PC and PE and PS to the other side. So move everything on one side. So we can rewrite this as PC subtract to the other side, we have -1 PC plus 0.4 PE 0.6 P the price of steel equal to 0. Second equation, subtract PE on the other side, so -1, we have 0.1 here, 0.1 minus 1 is -0.9. .2 PS, and because that equal to 0, we do have the homogeneous system, right? And then 0.4 the price of coal, 0.5 the price of electric, and subtract 1, we have 0.2 minus 1 is 0.8 the price of steel. Right, we do have a homogeneous system here, so of course put in matrix, reduce row echelon form, and that's it pretty much. Augmented matrix. Right. Right. -1, 0.4, 0.6, 0.6, -0.9, 0.2, 0.4, 0.5, and -0.8. Right. You can always write the reduced row echelon form in the fractal form. -31 over 33, 0, 1, -28 over 33, and 0 everywhere else. Right, we continue here. Of course, here we have the price of coal, the price of electric, and the price of steel. Right, so we have the pivot of the first two columns. So the price of steel is going to be arbitrary. Right, so we write the solution. So write the solution. The top equation is equal to PC minus 31 over 33, the price of steel equal to 0. The second equation is the price of electric minus 28 over 33, the price of steel equal to 0, and the price of steel is arbitrary. Right, and then we can rewrite as the price for coal is 31 over 33 so that's about 93.93 something, and then the price of electrics 28 over 33 steel, and then the price of steel is whatever it is arbitrary. So, and you say why don't we have a unique solution? Well, because we shouldn't have the unique solution. Let's think about this. Suppose we have just $1 million for the price of steel, and with that we can calculate the price of electric and the price of coal, and that is the equilibrium price. It will balance all the industry, all those three sectors of economy. Now instead of $100 million for the price of steel, we have $1 billion for the price of steel. Then we just scale everything up. So depends on one level of it. It will be equilibrium. We just scale everything up with respect to, in this case, the price of steel. So for example, let's say the balance between the three industry or three sector is 1, 2, and 3, with the ratio 1, 2, and 3 respectively. It doesn't matter if it is 1 billion or 1 million, as long as the ratio between them are the same, the price will be equilibrium. So that's why we have infinitely many solutions in this case. Of course, we can solve for one of them, and then we scale everything relatively to that. Right, so that's the first example. The second example is less common, even though I took a lot of chemistry long time ago, and we rarely use this method to balance equation. Right, but of course, I guess the only reason that we didn't use the method to balance equation using the system of equation, because it requires a lot of work to explain the math, I guess. Anyway, so we have the chemical equation. It's just we have some chemical, some substance, and mix with each other, produce some other substance. In this equation, what we have here is C3H8, that is propane, and oxygen. So pretty much we burning gas or burning propane, produce carbon dioxide and water. Right, so very basic. And to balance the equation, we have to have the same of carbon on both sides, the same amount of hydrogen and oxygen or whatever the element we have to be balanced. So first, for carbon, how many we have? There are 3 of them here, times x1, so we have 3x1 on the left hand side, and then on the right hand side there's 1 in carbon dioxide, so we have to multiply x3. So to balance the equation, we're going to have 3x3. I don't know why I put the 3 there, sorry. Right, So we have 3 carbon in one molecule of propane, so we need 3 times x1. This one only 1 carbon in the carbon dioxide molecule, so we only need 1 of them. And then for hydrogen, there are 8 of them here. And then on the other side, there are 2 in a molecule of water multiplied by x4. And then for oxygen, there are 2 in each molecule of oxygen, so we have 2x2. And then on this side we have 2 oxygen in the molecule of carbon dioxide, so we have 2x3. And then 1 in water. Alright, so that's what we have. So to turn this into the system of equation, move everything on one side. 3x1 minus x3 equal to 0. ax1 minus 2x4 equal to 0. 2x2 minus 2x3 minus x4 equal to 0. And we write the matrix, reduce to echelon form, and have solution. This we should have infinitely many solutions. You know why we know that right away? We have 4 variables, x1, x2, x3, and x4, and we have only 3 rows, and each row can only have 1 pivot at most, right? So we have at most 3 pivots, but then there are 4 columns for 4 variables, so one of the variables have to be free, right? 4 variables, 4 columns. On the left hand side of the geometric matrix, we can only have at most 3 pivots, so one of them has to be free. Right, so put in the matrix then. 3, 0, -1, 0, and 0. 8, 0, 0, -2, 0, 0, 2, -2, and -1, 0. And we'll just do reduce row echelon form. Right. Notice that on this one the last column is 0, so doesn't matter what I do with it, it's still left with 0. Doesn't matter what row operation we do, the last column is still 0. So we're just going to enter the left hand side pretty much, knowing the right hand side guaranteed to be 0. Change it to fraction. I said the last column has to be 0, because it doesn't matter what we do in the row operation, it's still just 0. I will have x1, x2, x3, and x4. As mentioned before, there are 4 variables, but only 3 pivots at most, so there must be 1 free variable. In this case, we have exactly 1 free variable, which is x3, x4. Sorry. Now I'll rewrite the equation. X1 minus 1/4 x4 equal to 0, first equation, x2 minus 5/4 x4, second equation, third equation, x3 minus 3/4 x4 equal to 0. Or if we rewrite, we got one last one, x4 is arbitrary. Or if we write the solution as x1, x2, x3, and x4. To solve for x1, I just move this to the other side. So we have 1/4, x4, 5/4, x4, 3/4, x4, and x4 arbitrarily chosen, so just x4. Right. All of them have x4, so we factor out x4. 1/4, 5/4, 3/4, and 1. Of course, those numbers are put in here, we balance the equation. But of course, x4 is arbitrarily chosen, right? So we choose some values that eliminate all the fraction. Since all of them divide by 4, so what we do is we're going to let just right on the next line. We're going to let x4 equal to 4 to cancel all the fraction. Right? If we have 4 multiply all of this, we have whole numbers. So we multiply 4 into here. 4 times 1/4 is 1. Just have plenty of space. Choose 4. That gives us 1, 5, 3, and 4. Right. Of course, we can choose 8 or any number for that matters. But if I remember correctly, in the chemical equation, they prefer to have the whole number with reduced as small as possible. So in that case, we write the equation as x1 is equal to 1. So we're going to have C3H8 plus x2 times oxygens. There are 5 of them. Produce x3 is 3 carbon dioxide, and x4 is 4 water. And so we can check real quick. There are 3 carbons here. There are 3 carbons. Hydrogen, there's 8 of them, and there's 8 of them. And there are 5 oxygen. So we're good. Right. Another one of this is a network flow. A network consists of point conjunction and would lie an arc. So in the arc between the junction, the direction of the flow on each plane is indicated. So amount or rate is either shown or denoted by a variable. So let's say we have this is the network shown is the traffic flow in 1 hour at downtown Baltimore. So we have 4 intersections A, B, C, D. You did not see this very clear, but let me write this again. So this is only one-way street. So go this direction. This direction. This direction. So it is one-way street. Oops, sorry, wrong way. Right, so all of this just one-way street. Of course, in real life doesn't have to be like this. You can have one way up to this point and one way on the other point, but that would be weird. Anyway, so it makes perfect sense that all the traffic, all the vehicle go through entering a point have to be equal to all the vehicle exiting a point, right? So that should be simple enough. So in that case, let's say for the node A, what are the total incoming traffic? It's going to be x4 incoming and x2 incoming, because that is the node B. Sorry. Right. For node A here, 300 coming in, 500 coming in, x1 out and x2 out. For node B, incoming is x2 and x4, outgoing x3 and 300. That makes perfect sense, right? For C, incoming 400 and 100. One and 4, and outgoing x4 and x5. For node D, incoming 5 and 1, and outgoing is 600. Once again, as you can see here, 5 variables, only 4 equations, 5 variables, so there will be 5 columns on the left hand side of the matrix. Only 4 equations, 4 rows, so maximum 4 pivots, so one of them has to be free. So once again, we should have infinitely many solutions. Right, let's rewrite this, move everything on one side. I'm sorry, write x and y on the variable on one side, the numbers on the other side. So the equation A, to rewrite that, we have x1 plus x2 equal to 800. Equation B, let's move x3 on the other side. x2 minus x3 plus x4 equal to 300. For C, x4 plus x5 equal to 500. And finally, for D, x1 plus x5 is 600. Right, put that in the metric matrix and then do reduce row echelon form. x1, 2, 3. 0, 1, minus 1, 1, 0, 300. 0, 0, 0, 1, x4, 1, x5, 500. 1, x5, 0, 0, 0, and 1, x5, 600. Right, our metric matrix, reduce row echelon form. Right. Okay, good. This up to 6 only. So if it's more than 6, we cannot do that on the home screen. We have to store at the matrix and do that differently. I did show this on the first video. Right, 1, 1, 800. 1, -1, and 1, 300. 1, 1, and 500. Oops. 1, 1, and 600. All right. Okay. Right. So once again, have 5 variables and only 4 equations. So that one of them has to be free. So x5 is free in this case because the pivot align here, 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 and here. So that is a free variable. Right. To rewrite that, I have x1 minus x5 equal to 600. x2 minus x5 equal to 200. If I copy this correctly, it's a plus here. x3 400. We do have x3 and x4 plus x5 is 500, and then x5 is arbitrary. Or we can just put that in the system. We solve for everything in terms of x5. x1 equal to 600 minus x5, x2 200 plus x5, x3 400, x4 500 minus x5, and x5 is any real number, but I'm not going to write any real number because it cannot be negative, right? So we should say in this case x5 should be arbitrary. I just say that, but with a little note. So it cannot really be any number. It cannot be negative for sure, and it cannot be more than 500. If x5 is more than 500, x4 would be negative. The other equation are fine. Here x5 can be anything because plus 200 guaranteed to be positive. But because we have this restriction, x5 cannot be more than 500 and cannot be less than 0. So in this case, with that, even though it's arbitrary, we still need to have x5 less than 500 and it still have to be greater than 0. We assume that at least one, or it could be 0, I guess. If x equal to 0, so that part of the street is blocked, so there's no traffic coming through. In that case, we do have the information for the others. So 0 perfectly fine. And of course, we cannot have half of a vehicle going through. So x have to be whole numbers greater than equal to 0, but less than 500. I guess we could be equal to 500. In that case, that part is blocked. So when we write the solution, even though we say arbitrarily chosen, we have to choose something that makes sense. Just like the chemical equation, we don't want to choose to be negative, coefficient to be negative. And also in here, of course, the price of steel, we have to choose something reasonable. We cannot choose negative price either. So that's the difference between the application and just a math problem. Math problem is pretty much when we say arbitrary, it could be anything. But in real life, we have to restrict the variable sometimes, so the problem makes sense. And with that, we complete section 1.6. See you in another video in linear algebra. As always, thank you for watching.